Alright, so for today we're going to go over 5.1, Introduction to Random Variables. Now, there's a lot here on the Big Ideas page, but we're only going to talk about a couple things here for today. So we're going to talk about being valid as far as all probabilities between 0 and 1, and the sum of those probabilities will equal to 1. And then we're also going to talk about being discrete or continuous. As far as discrete, being fixed set of values with gaps, example like number of siblings, which we're going to go over that here in a second, and continuous, all possible values with no gaps. So something looking at like height, like you weren't born and automatically 6 feet taller, right? You continuously grew, so it's continuously growing value for your height. Same with your weight. And with time as well, right? Time is continuously moving, seconds are going, so everything's all connected. So therefore, no gaps, it's continuous. So we're going to talk about those. So let's look at this then. So we're talking about siblings, right? So last year in one of my classes, we did this, and this is the setup they give us for the probabilities of the number of siblings. So X is the number of siblings they have in their family. So that's including themselves and brothers, sisters, okay? So we'll look at this to start off with. Our X value, is that going to be categorical or quantitative? So this X value, I'm talking about right here, this X value, these values right here for the X. That's 1, 2, 3, 4, 5, 6. Are those quantitative or categorical? Well, hopefully you see that the X values are quantitative. Quantitative. I noticed a little flashback there from the beginning of class. But again, quantitative are number values, and categorical are words, right? Categorical style. So with this, what we talked about for our big ideas that we were just looking at, right, is finding out if all probabilities between 0 and 1, so all our probabilities between 0 and 1, looks like we got everything in fraction form there, so it's less than 1, all right, and greater than 0. And then we're going to look see those sum of probabilities equal 1. So we're going to look at this and add all these guys up. That's how we would determine if it's equal to 1. So to do that, we'd take 2 over 26, plus 5 over 26, plus 5 over 26, plus 5 over 26, plus 3 over 26, plus 6 over 26 for the last column there. Alright, and if we did that, we would get, let's see, 5, 10, 15, and then 2 and 3 is 5, that's 20, and then 20 plus 6 is 26. We would get 26 over 26, which that gives us 1. So we checked off there. So we have all the values between 0 and 1 for probabilities, as well as they all added up to the value of 1. Now with looking at these values, we have that set up there for the amount of people that have scratch. So now we're looking at our X values. We said number of siblings, as far as saying 1, 2, 3, 4, 5, and 6 for a number of siblings. Would it be possible to say your X value would it be possible to say your X value is, let's say 5.7167? Can we have a sibling that was 5.7167? Can we have the number of siblings that? No, you could not have that, right? You couldn't have a decimal or a fraction of a sibling. You can have 0.7167 of a sibling. So with this, you could not have that. It would not work, right? This number would not work because no, you cannot have a fraction of a sibling. So that is going to be looking at the discrete gaps, right? In other words, we're discrete in our setup for our number of siblings. There's gaps in between them. So therefore, this number of siblings, they are discrete. All right, so now let's look at some just probability values here. So if we have these values and you were asked to find the probability of x greater than or equal to 3. Well, to find that, right, you're looking at the probability of your x value as far as equal to 3 plus the probability of your x equal to 4 plus the probability of x equal to 5 and the probability of x equal to 6. So with that, our probability values we get for those are listed up here above, and we should add them up. So 5 over 26 plus 5 over 26 plus 3 over 26 plus 6 over 26. So you should get 19 over 26 to get that value. And that is the probability of x greater than or equal to. So then let's look at, say we wanted to find, let's just say probability of x greater than 3. So we would do all of those again, but without including the probability of x equal to 3. And that gives us, let's see, 8 plus 6, so that should give us 14 over 26. So we see, of course, with the equal sign, it's saying including that value, and if it's just greater than or less than, in the case, it would be excluding that value and everything either below or above. So one little thing we'd like to talk about too here is now is what if we said that our y values were equal to time, right? So if our y values, let's say these values here, instead of our x value, let's say our y value, what if our y value, in other words our probability, was time, okay? And that equaled 5.7167. Is that possible? So would that make sense? Yes. This would work because you would have 5 minutes. You would have 5 minutes and then we calculate out to 43 seconds. Okay, because at 0.7167 we calculate to 43 seconds. If you took that 0.7167, multiply it times 60, you would get 43 seconds. So it would make sense if it was time, it would be continuous, not discrete. So hopefully that explains a little bit of something about dealing with probabilities between 0 and 1, sum of probabilities, as well as what discrete and continuous are. So hope you learned a little bit of something today, and I'll see you next time.